Okay, so we're going to talk about multivariate regression. This is Catherine and Melissa. So what questions does multivariate regression answer? It's a test that predicts the relationship between more than one independent variable and one dependent variable. It determines how much the dependent variable y is affected by one independent variable x1 when the second independent variable x2 is removed, as shown in the picture in the corner. A benefit is that we can choose the variables that will increase the amount of information for a better prediction of the dependent variable. So when to use this test? There are 3 questions that multivariate regression answers. The first one is a causal analysis. For example, do body weight and protein intake have an influence on VO2 max? A second type is forecasting an effect. For example, with x1 alcohol consumption and x2 hours of physical activity have on life expectancy. A third question is trend forecasting. For example, what is the effect on life expectancy of daily fat intake and daily physical activity level? So are there any alternatives to multivariate regression? You can use canonical correlation analysis, path analysis, and structural equation modelling. The assumptions of multivariate regression are that it's a linear relationship, that the data is normally distributed, that there's no or little multicollinearity, I'm not sure if I said that right, and homogeneity of variance. So restrictions or cautions associated with multivariate regression. The data needs to be normally distributed. The ratio of subjects to independent variables should range between 20 to 1 and 40 to 1, and there should be no less than a 5 to 1 ratio. There can be a problem with outliers, as this can produce a greater effect on the regression equation, and they can be difficult to find. There's 3 methods of multiple regression. The first is forward selection. This starts with 0 variables in the algorithm and adds 1 independent variable at a time into the equation. The second is backward elimination. This starts with all variables in the algorithm and subtracts 1 independent variable at a time from the regression equation. The variable that decreases r² the least is removed. If the decrease is found to be non-significant, the variable is removed. This process continues till the r² is found to be significant when the variable is removed. Then the variable is placed back into the equation and the process stops. The third method is stepwise. This follows the same process as forward selection, however in each step of the algorithm the variables that have previously been selected may be removed. What information is needed to conduct this test? Data that includes 1 independent variable and at least 2 independent variables. So the data analysis software program that can be used is SPSS and Excel. So conducting the test. So you open up your data file, go to Analyze, Regression, Linear, and then you move your dependent variable over, which for us is science score, and your independent variables. Enter your method as well. We're doing a stepwise one. And enter the method again. Then click on Statistics, and you can select what else you want in the output. Continue, and then OK. So the reported outputs or significance, is shown in this table in the model summary. So for us, all models were found to be significant, with the reading of f equals 130.4 and p less than 0.001. For writing, f equals 21.2, again with p less than 0.001. And for maths, f equals 17.3, p is again less than 0.001. So all of these are good predictors of science test score performance. Then you can look at the R-square change. And then you can look at the adjusted R-square and see what percentage each variable accounts for the variance of the dependent variable. So for us it was 39.4%, 45% and 49.2%. You can also look at your unstandardised coefficients and the significance of these. So for us, these were 0.302, 0.207 and 0.319, and they were all significant because they were less than the alpha value of 0.05. So to work out the final equation, you take this from the unstandardised coefficients, the b values. So our equation was 8.407 plus 0.302 times the reading value plus 0.207 times writing plus 3.15 times math times the error plus the error.